Hey guys, welcome back to another video on Quantified Oaks. Jumping into the details about how I set up each factor, why I set them up the way I did, and how they work. So let's jump into it. So the first factor I knew I wanted to test was temperature. So we're in my basement, I'm in Wisconsin, and my basement has some heat in it, but the walls are exposed, it's an unfinished basement, and it pretty much drops in temperature a fair amount in the winter. You know, we're down here, we do some laundry down here, store some stuff down here, but we don't really live in the basement. So we just kind of let the temperature go down in here as the ground temperature and the outside temperature, gets down pretty low in the winter. So what happens is the ground or the dirt temperature of the samples I had last year, they got into I would say like the high 50s. I didn't have a thermometer last year, but you know it gets pretty cool down here where you definitely want to have like some long sleeves on when you come downstairs. So I knew right away that I wanted to control the temperature in this test setup because I'm an engineer and temperature is one of always the factors whenever you're trying to design something, whether it's a product or an experiment. You want to make sure that you understand the temperature because temperature just influences so many things in life. Whether you're talking about the mechanical properties of a structure or if you're talking about a chemical reaction. And certainly when oak trees are growing, you know, they have mechanical characteristics, they have chemical reactions going on inside of them. They have different signaling factors that are happening inside the little growing plant. And then they have just the fuel itself that's in the seed, in the acorn, that was stored by the tree that produced the acorn. And so all those things get influenced when you start talking about temperature. So I knew I wanted to test temperature. So the way we control temperature is with a temperature controller, a heating mat, and a thermocouple or a temperature sensor. So each of our four little groups has its own temperature controller on it. So the temperature controllers here, this one and that one, they're both set to 75, and this one and that one are both set to 65. Each one has its own individual heating pad underneath. That means we're only heating from the bottom up. And then the thermocouple, or the temperature sensor, is halfway into the dirt in the middle carton. So what that means is, if that temperature sensor is underneath the set point, so in our case 75 degrees here, then it will turn on the switch in the controller, the heating pad will heat up, it'll get hot on the bottom, and it'll slowly raise the temperature from the ground, or from the bottom of the dirt on up. And then once it achieves 75 degrees, it'll turn the switch off. Now, as you can imagine, since the thermocouple's in the middle of the dirt, actually everything underneath that thermocouple is actually going to get a little bit warmer than 75 degrees, and everything above that's going to be a little bit cooler than 75 degrees. So really, when we say we're setting it at 75 degrees, we have to imagine that there's some gradient or some difference of temperature at the bottom of the dirt all the way to the top. But the important thing is we keep them all the same. The controller is the same, the heating element's the same, the thermal mass, or the amount of dirt in our case, is the same, so that it's a relativistic guide that we can say, okay, at least this temperature is warmer than this temperature. Because if we had a different type of heating element or controller, that they might not be apples to apples, let's say, and you couldn't necessarily compare them. So we can compare these, but I can't take a look at somebody else's experiment and say, okay, my 75 degrees will always 100% correlate with their 75 degrees because their temperature controller and temperature setup might be a little bit different than mine. Overall, I'm really happy with the way the test setups work. They're straightforward. It was easy to set up. I am a little bit worried that the outside containers and the very outside edges might be a little bit cooler than the inside one. So I did add some insulation here, and I might still do a little bit better insulation on the outside. But overall, it's working really well. At the filming of this video, we're about 2 months in, and I can already see a difference between the warm and the cold temperature settings and the results. So stay tuned for those results as they continue to roll in. All right, let's talk about lighting. Now, lighting's really interesting because obviously all plants need light to create energy, to create the fuel they need to grow. Seeds or acorns, you know, they have stored energy. That's mainly what a seed is, right? It's stored energy. But after they use that energy up, they need to create new energy to continue to grow. So if we're trying to make the biggest, healthiest saplings we can, we want to give them as much energy as possible. Now, last year, my lighting setup was subpar, let's say. My lighting source was 3 or 4 feet away, It wasn't very intense light, and it wasn't very focused light. And it wasn't light that was specifically designed, as far as their wavelengths go, to grow plants. So this year, I wanted to test mainly a cheap light that wasn't formulated or wasn't designed to grow plants, but maybe it was fairly intense, but otherwise nothing special to grow plants. And I also wanted to try a light source that was specifically designed to grow plants. There are a few wavelengths out there that, as far as people on the internet say, are better for growing plants. I don't know if that's true or not. And I thought, well, that'd be a fun thing to test, right? Can we determine, is the cheaper lighting source just as good, or is that more expensive, designed for growing plants, really worth it? So the last factor about light is time. How many hours per day are we going to turn these lights on? Last year, I had a light on 24 hours a day, but again, it was really dim. It was only about 1,600 lumens that were actually on the tree, and which isn't very much compared to sunlight. So this year, I knew I was going to have a lot more intense light, and so I thought, well, maybe I shouldn't have those lights on all the time. You know, our human bodies have a circadian rhythm. I believe plants do too. And so I said, well, let's try to mimic a rhythm that the trees might experience out in the wild. From what I can see, the most sunlight a tree in Wisconsin would experience in the middle of the summer would be 16 hours. So that's how these lights are set up. So I was able to just hook these up on my smart home, quickly set it up so that they come on in the morning, turn off in the evening, give exactly 16 hours of not sunlight, but of artificial light to mimic the sunlight every single day. So I'm really excited about the lighting this year. Those two kind of cheapo shop lights over there, they have almost 10 times the amount of light that I had last year. So they're up to 15,000 lumens at the dirt level. And these have 25,000 lumens at the dirt level. And they're apparently specifically formulated with the wavelengths that are right for growing. So, I mean, really, if lighting is important to these little saplings, we should really see some differences, not only here, but also compared to the trees I grew last year. Okay, let's talk soil types now. So actually, this was not the soil experiment I wanted to run. My initial idea was to run a store-bought potting mix versus a homemade potting mix with some compost that I would make myself here at my house. I tried that. I had about 2 or 3 months on the compost. It wasn't really breaking down. I don't know exactly what went wrong with it. Hopefully I can work on that next year and set up a different experiment with homemade potting mix. So this year I decided, well, if I can't make my own, let's just test 3 different potting mixes. So that's what we went for here. So I decided just to buy my soil. I went online and started doing just a little bit of research and found out that actually, let's see here, potting mix is what you can just take out of the bag and put in your planter and use. And potting soil actually should be mixed with some other stuff to give it the right consistency in your pots. So I went out with potting mixes, but actually one, let's see here, Burpee is actually called a growing mix. Honestly, I don't even know what the difference between a potting mix and a growing mix is, but that's what I got. And so we're kind of testing those out this year. So I have Miracle-Gro, Espoma, and Burpee. Now, 2 of those are brown in color. That's the Miracle-Gro and the Burpee. And then the Espoma is actually quite black in color. Now, a farmer friend of my dad mentioned that you should be using the color of soil of what you have in your yard or wherever you're going to plant the thing you're growing. So if you're starting any type of seedlings, whether that's a vegetable or a tree or whatever, and you're going to go plant it out in your yard, you should use the same color soil. So I don't know if we're going to even see the impact on the different soil types here, or if that'll be more important once we actually go transplant them into the wild here. But it is interesting, and I mean, it was one thing that stood out to me right away was that Espoma was quite a bit blacker. I mean, it was black compared to the other 2 soil types that are brown. Each potting mix has its own claim of why it's going to be the best potting mix. Miracle-Gro, it claims that it is specially formulated for root development. That'll be hard for us to observe directly, but maybe indirectly we'll see some better tree growth out of it. The Espoma has a lot of natural organic things that it thinks it's going to help feed plants. Things like earthworm casings, alfalfa meal, kelp meal, feather meal. So they have added a lot of extra things, and you can observe that. I mean, it looks quite a bit different soil-wise. And then the Burpee one, That is an interesting potting mix because it actually advertises the NPK numbers, which are the fertilizer numbers that are in the soil itself. So I don't know if they monitor that or if they're adding more fertilizer to get those NPK numbers, or if they just know that about their soil type. I think it's really interesting because as an engineer, I know that any specification that I advertise, I need to control. So the fact that they have control over the NPK in their soil is definitely super interesting to me. The other thing I'll say about the burpee that I really like is nothing extra is growing in it. I don't have any extra mushrooms, any extra plants, any extra fungus growing on the surface. The burpee seems like the only things that are growing in there right now are my trees, and that is definitely a win for me. Okay, so I wanted to talk about the planters or the pots I'm using here. I'm kind of using that term loosely, obviously, because they're all reused drink containers, mainly milk containers, probably a couple lemonade containers in there from summer. So I picked these because I didn't want to buy pots, and also I really like the dimensions of them. So they're fairly tall. They're almost 8 inches tall after I cut the tops off. They're almost 4 inches by 4 inches this way. So I think we can get plenty of dirt in there. After I looked at my root system I had from my red solo cups last year, the red solo cups were definitely a little bit small, and the roots kind of hit the bottom and kind of started following the curve there. So we only want those roots to go, straight down. We don't want them going off at any funny angles. And also, since they're rectangular, they fit together well. So I'm able to set my heating experiment up kind of nicely here. If they're round containers, I'd have all the space in between them, and that means my lighting source would have to be further away so that I could get it wide enough. And I don't know, this container profile really worked out well for me, so I'm really happy with it. So last year, I think I really overwatered my saplings. I think a couple of them probably even died because I was watering them so much. There was a drain at the bottom of those containers, but I was watering so much that the soil was always really wet and damp, and that just probably wasn't good. So I wanted to measure and control the amount of moisture I had in the soil this year. Not so much that I think it's going to affect the growth rate, maybe it will, but I really think it'll affect the disease rate, let's say. So I had this one tree last year that I thought it was dead, I thought it was a goner, so I took it out of the kind of group that I was keeping and just kind of put it off to the side and didn't water it for like a month. Well, about all of a sudden, I noticed that the thing was growing and the dirt was like, really pretty dry, and I was surprised that if that sapling could survive in such dry dirt, I did not need to be watering the other ones as much as I thought I did. So that was kind of a learning experience for me and why I wanted to use that here. So I bought some moisture meters. I don't even know what units they are. They just have a scale from 1 to 10. They have the bottom 3 is, they call it dry, the middle up to 7, I think, is moist, and then from 7 to 10 is wet. So my goal here is to keep one row in the dry column, one in the moist column, and one in the wet column all year, so that we can see, okay, does the moisture level affect the growth rates? But I think more importantly, is there going to be a disease rate difference in the 3 different moisture levels? So the soil moisture meters that I have are representations of the row that they're in. So this entire row will be the dry row, this row will be the moist row, and this row will be the wet row. So when that meter is out of its bounds, I will try to rectify that on every single row that it represents. So for instance, if this row is getting a little bit too dry on that meter, I will add the same amount of water to each planter in that particular row. So the way I do that is with a little 2-ounce container, and that lets me control the amount of water I put in every single container. So that way I don't have to get a moisture meter for every single planter that I have here, and I can just use those 3 to help me control the amount that's in every row that I have here. Of all the factors, this one I think I still need to dial in a little better. I'm currently just using the frequency of watering to try to control the moisture level in each one. I only have one size of container that I add water to. Certainly I could try to keep the same frequency and just have 3 different size containers. We'll see how that works out exactly. So the last factor is burying depth. That was kind of an add-on or kind of something that wasn't very planned as far as my factors go. I ended up collecting over 100 acorns with my wife, and I didn't know how many I was going to kind of fall out when we did the water tests, if they sank or they float. And I ended up with over 100 acorns that were viable. And I really only wanted one tree per container. But I knew that some, even though we did the water test, some still might take. So then I said, well, let's put a couple extra acorns in each one, and then we'll just pare them down after we know that they're working or they're viable. So since I knew I was going to be putting multiple acorns in each pot, I said, well, let's just vary the burying depth on each one just to see if that has an impact. And let's just find that out, because I have seen some people say, well, you actually don't really need to bury the acorn because the taproot will go down on its own. And other people will say, well, you should really push it down at least an inch into the dirt. So that's what we're testing here. I really only want to end up with one tree though. So actually what I'm going to do is, after they've all come up and they all have some leaves, I think we'll just pick the strongest one and take out kind of the weaker trees, so that we only have the best ones growing for each pot. At this point in the experiment, I'm really happy that we had this factor, because certainly we had some acorns that dropped out. The floating test did not separate out all the unviable acorns. So I'm certainly happy that I planted extra acorns in each one. And yeah, just in general, happy that we have this factor. And I think I'm already telling that the ones that were buried a little bit lower are actually doing better. So that's the experiment. That's what's going on right here. If you'd like to stay up to date, hit the subscribe, hit the notification button. I will be doing quantified updates to track the progress of the saplings as they grow here and once we transplant them into the ground.